Okay, good day to you all. So let's start off. So I'm going to try to explain what the lead acid battery actually is. So I've got a diagram over here. I drew this myself, so I'm very sorry if it looks a bit wobbly. And then this is another one from my textbook, right? Okay, let's start. So normally as an electrochemical cell, we have the anode, we have the cathode, we have its electrolytes, and then we have the circuits that will carry the electrons through it. So we all know that the anode is a lead metal. Let's say it's a lead metal, and lead metal is composed of lead atoms, right? So there are plenty lead atoms here. This is lead Pb. So there are many of those atoms that come together and then they form this metal here. The cathode is from lead 4 oxide. So this is lead 4 oxide. They just come together to form this side. Our electrolyte is sulfuric acid, and this sulfuric acid is broken down into hydrogen and tetrasulfate ion. So now let's move on. How does this process actually work? How does it move? How do the electrons form to pass here? And then let's think of this as a light bulb. How does it move to light up the light bulb and stuff like that? Let's start. So first of all, we have the lead electrode, right? And we all know that in this side, in the anode, oxidation occurs. So let's see the way this goes. We have lead ions, lead metals. These lead metals, they are dipped in an electrolyte. So let's say they are dipped in a liquid, right? So because they are dipped in a liquid, they break down. Because they are liquid, because let's think of this as a liquid. So this lead electrolyte is dipped inside. So because it is dipped inside, it is broken down. Like it starts to break down into lead ion and 2 electrons. How does this work? What do I mean by this? Let's think of it this way. When we have a metal, right? And the metal, we know that lead, it has a valence electron, 2 valence electrons, right? If lead turns to an ion, it forms this. Lead with a 2 ion charge here. So that's it. When it breaks down, it forms the lead ion, but it's lost 2 electrons to form this lead ion. So those 2 electrons will stay on the anode electrode right here, while the lead atom, which has broken down into the lead ion, will enter into the water. But the electron that it lost to become Pb2+, the electron that Pb lost to become Pb2+, will still stay on the electrode. But the Pb2+ that we've gained will be the one to enter into the electrolyte. So our electron is still here, but the ion has mixed with the electrolytes. So I hope you are getting it. And this process is continuously occurs. So we have many Pb forming into Pb2+, and then their electrons are the one gathering on the electrode. Those electrons that gather on the electrode will not be the one to come up and pass through the wire, and then they goes through the wire. And we know it that current is the flow of electrons, right? And objects need current to pass through them for them to work. A bulb, current flows through it before it can light up. So let's think of this as a bulb, right? The electrons that gather over here due to the breakdown of these lead atoms, those electrons pass through the wire and into the bulb light. Because electron is flowing, which is literally what current means. Current is flow of electrons. Because electron is flowing through this bulb, the bulb will literally lit up. That is the same way the car also works. It's onto current that the thing will start to work. So let's think of this as a bulb though. So because electron is flowing through, the thing will lit up. Now, electron has flowed through it and is now continuously passing through this wire. And as it passed through this wire, it comes down and then it reaches the cathode side. Now let's see how the cathode will work. So the cathode here is PbO2, which is lead 4 oxide. And then one thing you should know is that lead 4 oxide has gained 2 electrons, the 2 electrons that were lost by the lead atoms from here. So we have, let me erase this. We have PbO2 plus 2E, right? We have PbO2 plus 2E. And then hydrogen from the electrolyte will now come to this side and attach itself here. So we'll now have hydrogen ion. The hydrogen ions from this side will attach itself to this electrode. So we have PbO2 plus the hydrogen ion plus the electron that was lost from this side and passed to this side to reach the electrode. So I hope you are getting me now. That is where you see this equation over. So PbO2 plus hydrogen plus the electron that we've discussed how the electron got there will give us lead ion plus water. So after everything over here, what we'll later get is lead ion plus water. So we have Pb2 plus, which is the lead ion, plus the water. So it's normal to know that the water will mix into the electrolyte, and also the lead ion also mix into the electrolyte. So that is to give you a sense that we have a concentration of many lead ions, because the lead ion that was gotten from here, and there's also another lead ion that was gotten from here. Don't forget that water is also here, so let's just squeeze that in. So the lead ion that's also gotten from here, everything just mixed together. What then happens? What happens? That is when you start to see that the lead ion mix with the tetraosulfate ion. So the lead ion mixed with tetraosulfate ion, they start to combine and they start to form salts, right? And then the two combine, we have PbSO4. So that PbSO4 that we have will now start sticking themselves at the surface of the electrode. So this side starts getting covered. Everything just starts getting covered with PbSO4. PbSO4. Even at this side as well, there's PbSO4, there's PbSO4. So let's think of the PbSO4 coming like this throughout the electrode. So basically, once the PbSO4 starts to coat around the electrodes won't be able to react anymore. The lead electrode, which is the anode, won't be able to release any more lead ions into the solution. And the cathode side, which is PbO2, it won't be able to react with any hydrogen, because the PbSO4, which is the source, is blocking the hydrogen from reacting with the electrode itself. Therefore, there won't be any more release of lead ions to form any stuff. So yeah, that's it. The electrode won't be able to work normally, and then the battery won't be able to actually function well. That's the way the thing actually works. I hope you're able to understand.